misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put flat earth in its place.
Welcome everybody to Tuesday night on a Wednesday. I'm your host MCToon. Normally on a Wednesday, FTFE and I do a combined live stream earlier in the day, but he had he's got a bunch going on, and so we weren't able to today. But I said, well, you know what, I can do it later today. And what should I do? Well, what I should do is I should have Jesse, who's right here, explain something that I think a lot of people don't quite understand, and that is this celestial theodolite that flat earthers just love these days, and I just thought it's a very convoluted and confusing method that they're trying to do. So Jesse agreed at very short notice, to talk about it, explain it a bit, and go over some of the stuff that he's done since then. Anyway, welcome, Jesse.
Thank you.
And I did send a link to Ruhif, who's also done a good deal of work on this particular topic. So we should have hopefully have a good understanding of what it is that they're trying to do and what it actually does. So.
Right. All right. Well, so shall we start with how it's supposed to work?
Yes.
I'm not going to go on for an hour like they would, but I think the basic idea started out. Ruhev, I see him. Do we hear him?
Hello.
Yeah, we hear him. Ooh, nicely.
Listen to that voice.
Yeah, that is a voice that could go on any radio.
Yes.
So,
Is it if I talk like this? All right.
You get people excited if you do that.
So the basic idea, if before it was bastardized to fit flat Earth, almost, wasn't a bad idea. The basic idea was, stars occlude over a mountain peak, or they could rise from behind a mountain peak. So if you simply observe it, that time of occlusion or setting or appearance, and record that time, then you can go into Stellarium and put in your location and the name of the star and the date and the time and your the barometric pressure for your altitude, and it will let me just kind of, these slides weren't prepared for today, so ignore the red text up here. But basically, Stellarium will compensate for astronomic refraction and will give you a very reasonably accurate prediction for the apparent angle of that star. So you can pretty much any time or place and star, and you put in your location, the star, the date and the time, and your barometric pressure for your elevation, and it will give you a very reasonably accurate apparent angle of that star at that moment in time. So the idea was, well, you could wait till the star occluded the mountain, at which point the apparent angle to the star would be equal to the apparent angle of the mountain, which would basically then give you kind of the ability to measure the apparent angle of the mountain without owning a theodolite. So, and that works. That does work. It gives you the same apparent angle that you would get with a theodolite or a sextant or whatever. So my guess is that's what they tried first, but of course that gave a globe angle, so they were dissatisfied with that.
Well, technically, they did measure it first, and it gave a flat Earth angle with their shitty level transit, right?
At some point they used a antique David White 8300 construction grade transit, which they called a Theodolite, but it's not. And it gave, they claim that it gave a flat Earth angle, but there was no pictures of the setup. There was no pictures of the readout. There was no pictures through there was no evidence that it actually happened. So it's hard to say what it actually gave if they did it. So I can't say whether they did or they didn't, but yeah. And then they also borrowed a real Theodolite and also vintage Sakia Theodolite, which of course gave globe results. So they threw out the Theodolite as a usable tool. But anyway, the method using Stellarium was a good idea if done properly, i.e. putting Stellarium at your observer location and leaving atmosphere on and putting in your correct barometric pressure. And I can also would you like a demonstration of that in Stellarium?
That would be really cool.
Please.
Okay.
Stellarium often doesn't broadcast well, though.
Oh.
It works.
Well, we'll try. Let me change my screen share and see what we get. New share. Stellarium. Share. Okay, what do y'all see?
I see Stellarium.
Okay. All right, so let's see. We'll just go to Efron's house here, and we'll go to stop the time, and then we'll go to see, to bring up the date setter here, and then just wait for it to get nice and dark. Oh, I'm going to do one other thing. There's a clever thing that the people who write the Peak Finder website have done. And actually, I think, Rufus, do you have some interesting things to share on this?
I do. I put a few on Twitter yesterday. So a couple of days ago, like Jesse and I were chatting, and we wanted a visual representation of the star actually being occluded by the actual mountain. And Jesse had previously imported like basically a vector graphic kind of line into Stellarium as a horizon, but it also has a bitmap graphic that you can import. So what I've done in the last few days is automate downloading a 360-degree panorama from uDeuschel, which is an awesome 3D terrain renderer. And then, automatically downloading it and then converting that into a format that Stellarium can read. And I posted a few of those, just needling Shane St. Pierre on Twitter in the last day or so.
On this channel, we pronounce his name correctly?
Shane St. Plagiaire.
There you go. Thank you.
Yeah. So I posted a few of those on Twitter. One behind Pikes Peak, like the canonical example that they brought up was a star in Aquarius going behind Pikes Peak. And I set that up in Stellarium with the actual 3D rendered background. And what do you know, at the exact time, that star goes behind the mountain as predicted by the globe. So, yeah, haven't seen a response from Shame yet, but yeah.
I have right here a paper copy of a book written by Michael Heffron. It's called
the ether rubbish.
No, it's called Ramblings of an Old Man About the Scientific Method.
I thought you were going to say my dissertation on my insanity.
He's an interesting character.
It is Chapter 5, Gravity. Oh my. It is a journey through the mind of an insane person.
Yeah.
Who can do a little math.
Sorry, another aside. yesterday, so I took their spreadsheet, a little bit of background. Jesse asked Dr. Mike to basically add one observation to this spreadsheet that they're using to keep track of the entire database of observations. And you guys were there for like an hour or 2 hours just trying to add a row to this freaking spreadsheet. I went through the spreadsheet yesterday, fixed it up. I'm a bit shocked that someone that is a PhD in computing science can't figure out the basics of Excel. That was pretty bad. And the thing that came out of it is just how much globe geometry they're using to fudge it back into a flat Earth. It's pretty hilarious. Anyway, Jesse.
Yeah, I have queued up here. Is this showing with the stars and everything?
Yep.
Oh, good. All right, so you can see I've clicked on some random star here. And just because it was a bright one, and there's Pike Peak. So you can see I've got the horizon imported from Peak Finder. It shows Pike's Peak and different mountains here. And here's Mount Rosa. And it's kind of a low resolution skyline, but it sure makes it easier to identify what's going on when you're trying to figure out, what star you saw in the video. This method for measuring the altitude angle to a mountain, the apparent altitude angle to the mountain, if you use Stellarium correctly, is actually very good. And really the weakest part is that it becomes incredibly difficult to see these stars as they approach the horizon because of the more air. The same way the sun gets dim as it sets, so stars do too, but they don't have as much light to start out with. So like...
But go back, so... You've got atmosphere on, but you'll see in the top left, you've got magnitude 4.65 reduced to 4.65 by 18 air masses. That doesn't sound right.
Right. So let me explain. I turned...
Okay.
You can go in and you can set the extinction coefficient, and I set it to 0 because I wanted to see some bright stars. So I'll set it to the default. Now this is the default, and you can see now... It's just it's not a very bright star, and it's 4.65 reduced to 8.2 by 18 air masses. So if, I picked, say, one that wasn't so incredibly bright to start with, like there's a 6, here's a 6.35, here's one that's around 7.
For those that don't know, magnitude as the number gets larger becomes harder to see.
Right. So here is a 7.2, which, on a good night, you could probably see it easily with your eyes, because about 6 or 7 is what average human can see with their eyes, I guess. And then higher numbers than that you can't really see. So here's one that would be visible to the naked eye if it were, overhead. And this is logarithmic too. So going from 7 to 10 is a huge step. So you can see this star is reduced to 10.5 by 17.6 air masses. So they do become a lot dimmer. So you need to use like time-lapse photography, which works and which is cool. Or I use a night vision scope hooked to my telescope. So anyway, let me go back and turn it. The extinction back down, just so we can see these wonderful stars. All right, so here's an example. Here's a star, HD 172594, whatever. And as you can see, as the time progresses, it comes down and clips behind the mountain, just like in real life. So the basic idea was decent. If you set up Stellarium at your location, and you can then find the star in Stellarium, and you can see what time, you can put in the time it clipped. So if this was on the date 9/11 and at 1:19:35 in the morning, in UTC -6, which I get, that's his time zone now. I have it set up for his location right now. Then you can see, you might not be able to read up in the screen here, But on the left upper here, it says altitude angle plus 2 degrees, 15 minutes, and 13.3 arc seconds apparent. So I think that's how they started out with their so-called celestial theodolite method, but obviously that's the angle that you would measure on a globe with a theodolite, which was not satisfactory to them. So Dr. Heffron started messing around. So then he goes in and he turns off atmosphere. And now you can see that made the altitude angle go down to 1 degree, 58.26. Well, that's not good either. So he's like, well, what if I move stellarium? So then he goes in to stellarium and let's see, location. From, let's see, Pikes Peak. So then he puts stellarium onto the location of Pikes Peak.
So he was
which makes
actually at his house. He was not actually at Pikes Peak.
Correct. But he was basically putting in fudge factors by moving it, because as you move it closer, the angle to the star rises by 1 degree per 60 nautical miles, just because that's how much the angle to a very, very distant object would appear to change if you moved on the surface of a globe with a 39, 59 mile radius. So he was just using the location of stellarium as a fudge factor that nobody would question, hopefully. So I've moved stellarium to the mountain peak now, and you can see this has brought the angle back up to 2 degrees, 25 minutes, 43 seconds. And this isn't the exact star he used, so it's not the exact numbers he was using, but that's closer to the flat Earth prediction because he added back in that elevation angle by getting closer. And by the flat Earth prediction, I mean, if you assume the Earth is flat and then you take and divide the height of the mountain, the delta height of the mountain by the distance to the mountain, rise over run.
You create a triangle.
Right, you create a triangle, and then you put that into arctangent, and that gives you the angle, the elevation angle to the mountain. So that's what they call their flat Earth prediction.
So to review, you solve a triangle. If the Earth is flat, then you could just do a lot of things with triangles very simply because you don't have a curving surface. But if the Earth is a globe, then that mountain that's, say, 60 nautical miles away, it will have dropped by a certain amount, and so then you can compute how much it will have dropped from that triangle. And so the globe method would be to solve the same triangle potentially, and then just how much would it have dropped over that distance.
Right.
Yeah.
So anyway, so then that was their trick for getting Pikes Peak and Mount Rosa to match the flat Earth. And so then they said, well, look, you know what? All these mountains, the two that match, they match. At the beginning, he had just done Blodgett Peak, and it matched the flat Earth prediction very closely, but he had forgot to film it, so all he had was his notes on a notepad where he had written down the times. And all those times were several minutes different than stellarium predicting the angle for the actual occlusions, so I think he had his time offset on those. When he went back and actually filmed occlusions behind Blodgett Peak, then they did not match flat Earth. They came in using his method halfway between flat and globe and slightly closer to globe. But anyway,
so they do two things. They pretend that there's no air, and they move the observer to the peak of the mountain.
Right. Yeah. Exactly.
And teleportation.
And what they got was, the flat Earth prediction for the observer on the ground, not on top of the peak, was 2.5. The globe prediction was 2.1, whatever. But when we turn off atmosphere and move the observer, we get back to something near 2.5. So, hey, what do you know? Let's pretend like that is some sort of an appropriate method for measuring the angle. Yeah.
Right. And so that was all fun and good until they gathered some more data, and I gathered some more data, and then it became clear that their method was not working. It was not following the angle of, or the arctangent of the rise over the run, and that there were massive non-random elements contributing to the angle which do not match the flat Earth prediction. So, and I showed this here when I was on before. Can you see the little tiny graph in the left here?
No, you're still on Stellarium, I think.
Oh, you're right. I am still on Stellarium, aren't I? Let's see if it'll let me switch back. Yes. Okay. Did it switch back?
Yes.
There we go. Yep.
Okay, good. All right. So this obviously is just my slide from when you had me on before. So I found that the real formula that matched their results was, surprisingly, based on the globe. It was apparent angle to the mountain minus astronomic refraction. Or no, minus, let's see, what was it? Oh, it's right here. Okay, globe apparent angle to the mountain minus astronomic refraction plus 1 degree per 69 miles to the mountain. That's the formula that actually matched their procedure, which they called the celestial theodolite.
Uh-huh.
Yeah, so that's their process in the red, and then blue is what they're comparing it to, and they go, oh, matchy, therefore flat Earth.
Right, and obviously for certain values of globe apparent angle and astronomic refraction, and for certain distances, for certain combinations of those, that does give the same final value as arctangent of the rise over the run, but only very specific locations where those numbers all just happen to jive. So what this graph here shows, the red line is the difference between my prediction using this globe formula and their results, and the blue line is the difference between the flat Earth prediction and them using their method. So you can see for Pikes Peak, their blue line is pretty close to 0. That means Pikes Peak happened to be at a pretty close, at just a sweet spot. And Ruhef has a nice sweet spot graph. Maybe he can share it.
Oh yeah, it's a, in a minute. It's a super graph. I love it. Yeah,
and so Pikes Peak was at the right distance and altitude to give reasonably close to flat Earth results in that particular case using this goofy method of theirs. Then Blodgett Peak was not, Cheyenne was not, Mount Rosa was almost spot on for flat Earth using their method. Blue Mountain was not. Greenhorn Mountain, using their method, came out 2,000 feet too high.
Did they use that in their measurement?
Eventually, they filmed stars setting behind Greenhorn Mountain and shared the data.
Oh, even though it didn't match.
Yes.
But Witsit said it matched perfectly.
Well,
it did.
To Witsit, perfect has a different meaning.
Oh. A modified definition.
I do have something to say on that. Their whole claim is that this negates refraction, right? And refraction is a variable that you can't predict it perfectly. If they claim to negate refraction, then what is their error? Like, why isn't it perfect? If there's no variability, what's the error?
Yeah, that's a very good point, because the reason why there is variation is because there is an unknown amount of precise refraction. There's an approximate amount that we know from some measurements, but it's approximate. and weather and other conditions can affect it. So if there's no refraction happening, as they claim, there should be no variation. It should be always right there in the middle.
Yeah.
Right, exactly.
I would love an answer to that from Alan and Dr. Mike.
And this is what I presented to them, because for a long time they maintained that refraction did not affect it. Now they're starting to hint that there's something called real refraction, which may influence it a little bit.
Real refraction. So just to that they didn't like the centuries-old method of measuring an angle to the peak. So they invented a different method that nobody's ever used before and has steps in it that there isn't any apparent reason why you'd use it. Then when they're talking about refraction, rather than using the centuries-old method of how refraction has been used, measured and used, they're hinting at using a different, untested, unknown method of how refraction happens. Okay.
Yeah. So, their claim is that, and this is absurd beyond description. Their claim is that because you're timing the moment that the star disappears, and that once it disappears, you're no longer seeing it, that there's no light to be refracted, so the angle of disappearance had to have been refracted. And yes, that's as absurd as it sounds. But
it's like you may as well close your eyes. If there's no light, it's effectively the same as having your eyes closed.
Yeah.
And therefore no observation.
You can turn off refraction by closing your eyes.
Yeah, pretty much. Yes.
So I kept bugging him with this, and eventually Alan did admit that refraction could change the occlusion time, but he said it would be too insignificant to make a difference. So,
and he presented the math and computations to back up that assertion.
I think the math was stop repeating yourself, Jesse. We're not going to answer that.
Not surprised.
We did have a fun stream on Earth Awakenings the other day. I got muted, I think 3 or 4 times. And yeah.
So anyway, they as more data was gathered, well, the big first snafu was Greenhorn Mountain, which came out 2,000 feet too high. And at first Alan was like, well, then the published height is wrong. And then I'm like,
Unfortunately for Alan, there is actually a survey benchmark, a vertical benchmark on Greenhorn Mountain.
Yeah, and so I'm like, well,
the hubris to think that their untested, unknown method that nobody's ever used in all of history is more accurate than centuries old and tested methods of surveying. The misplaced hubris is beyond belief.
Yeah, and so, but anyway, I was like, if you're saying it was 10 feet higher than published, okay, whatever. But 2,000 feet high is enough that it's going to collect a lot of very unhappy pilots. So this is something we would have known about. This is something that would have been corrected. It cannot have been 2,000 feet high. And he admitted, yeah, you're right on that one. So kudos to him for that. So then the next snafu was after I figured out the formula that perfectly modeled their results based on the globe, I then went to a location that would give perfect globe results. So this Blinn Mountain number 1 here was at the correct distance and height and everything in my area to get spot-on globe results, because they had said that that was impossible, so I had to test that theory. And I did that from 2 different locations to the same Blinn Mountain. And so at that point, they realized they needed more fudge factors.
Well, I mean, more fudge sounds good.
Yeah, I guess so.
If you go to the ice cream shop and you're like, hey, can I get fudge? Like, yeah, there's a little. No. I need more fudge.
But their fudge factors rely on the globe as well. Like this whole thing is just globe geometry through and through. That the spreadsheet is phenomenal. I've got to send it to you actually.
Is it
Actually-
actually an Excel spreadsheet, or are they doing it on Google Docs?
Excel, yeah.
Oh my
Yeah.
gosh. You can't share an Excel spreadsheet like that. Just Google Docs, people.
I don't know. Can you do cool stuff in Google Sheets or whatever?
Yeah.
I like
yeah.
Excel. Excel's good.
So
you can.
I
everything.
just import his sheets into Google Earth and or into
Google
Google
Sheets,
Sheets, and
yeah.
then
Sheets.
then I can share them and edit them, and anyone can, it makes it pretty convenient.
Can you do like Lambda functions in like the name manager kind of thing?
I'm not sure. I'm not familiar with Excel because I stepped off the Windows train about 1997.
You did. Yeah.
So, but first of all, his sheets do work. So whatever he's doing does work. And secondly, what Google Sheets does allow you to do is write in JavaScript custom functions. So like, you have your average and your stdev, your standard deviation functions. Well, you can write your own in JavaScript and then use those in your cells. And so I found that very, very handy. I put it in Haversign.
I retract my criticism. So,
Anyway, so
you can do Lambda functions.
okay, cool.
yeah, I'm not even. I think is a Lambda function like an unnamed function almost or something.
Yeah, inline basically. Yeah.
Yeah. Well, I just go and create the extensions JavaScript file, a sheet. It's just real add. You go into extensions or whatever, and there's your JavaScript, and
Cool.
you just put it right in there, and it's cool because you can have your functions. They can call each other. You can have global constants, and you can have I'm not sure what all you can have, but your functions can definitely call each other. So I have one function for converting DMS to degrees. Then I got another function for doing Haversign, and it takes two full DMS pairs, and it uses the DMS to DD function to
Yep.
split that out. So I think it's very powerful.
DMS is degrees, minutes, seconds
Yes.
for the viewers.
Yeah, just unless they think we're talking about some substances that should not be consumed or
Well,
something.
they thought you were talking about a Dungeons and Dragons module.
Oh, well, nope. So anyway, so you can see on the right here, I'm about done with this shot here. You can see I did a histogram on the error between their prediction and their measurements. And you can see it's all over the board. It's got 3 high peaks in different locations. One is for these mountains here, one is for Greenhorn Mountain, and then the third is for my globe match results. But you can see the histogram for the difference between my prediction and their results was very clean, a very standard distribution. So at this point, it should have been clear to them that their method was just a result of the Earth being a globe, but that wasn't where they wanted to go, I guess. Oh, do you have anything to throw in, Ruhif, or should I go on to my next slide?
He popped out for a second. Oh, there it is.
When will that?
Soon.
He doesn't sound popped out.
No, didn't pop out. Had a visitor who wants to watch me. Okay, all right, off you go. Okay, there we go. Anyway,
What wants to watch you crush the flat earthers?
yes, exactly. Yeah, continue.
Okay, let me just see if I can find. Let's see. I'm looking for Mount Rosa. Here we go. So this is kind of a messy diagram showing how their best data point, Mount Rosa, which using their method did match flat Earth. So, their claim is that they're having a straight line of sight to the star, and that's that.
Through the mountain,
Well,
somehow.
this diagram just shows what's happening, and this is a globe representation. Yeah, I even have the ground curved slightly
Oh,
here.
you
if
do,
look
yeah.
at the green grass.
Now, I think it's worth pointing out that they conclude it matches the flat Earth prediction. But the thing they're calling the flat Earth prediction includes Stellarium computing the position of the star in the celestial sphere. It does not include computing the position of the star based on where it is on the celestial dome, or as some flat earthers have asserted, on the celestial plane. Right?
This the spreadsheet that we're talking about that got sent around literally has the right ascension and declination of a star, and then uses sphere geometry to work out the azimuth and altitude of that star. Swear to God.
It's what the video that I released yesterday was a flat earther doing celestial navigation. And he used 60 nautical miles per degree. He's like, oh, look. And he goes, he got it all wrong. He was 284 nautical miles off. He goes,
that's right.
Boom.
Yeah. Boom.
There you go.
Yes.
Boom.
Yeah.
Oh, my gosh.
Jeez.
This
is why I almost refuse to believe this guy has a PhD in computer science. Like, you need some level of mathematics and geometry to do computing science, in my opinion. For him, it screams Poe that he would just blatantly use a globe like that and then somehow conclude flat Earth.
No, you read this.
I mean, even using Stellarium in the first place.
Read this book. It gives you an insight into the insanity in his brain.
Okay.
We actually, somebody, I don't remember who, did find the first few pages of a dissertation by a Michael Heffron in computer science, and it was signed off on by 3 professors. I haven't checked to see if those are actual professors of an actual college, but unless someone's outright just frauding that, he actually may have that PhD.
Could do. Could be Liberty University as well. That's a possibility.
It was a technical university in his state, Colorado.
Okay. Cool.
So
where's Liberty? Where's the Liberty Shack University?
Liberty's on the East Coast, I think.
Okay. Hang on. Are we talking about the same thing?
I don't know.
Maybe. I don't know. But it's just a shack that is a diploma mill or a graduate. Yeah.
No, Liberty, the one on the East Coast is a real university.
Okay.
yeah, no, his was from
Colorado Spring. Let's see, dissertation. I have it here. In candidacy for the degree of Doctor of Computer Science, Department of Computer Science by Michael Heffron, December 2001. Approved, was he Colorado Technical University?
that's
three
what I was
different
thinking.
the chairman and 2 other PhDs from the university there. So
his brain has gone to mush in the last 20 years.
it could be.
Colorado is a green state, so you never know what happens in 20 years.
True. How long's it been green though? 10 years?
Oh, I don't know. Washington only went green a few years ago.
Yeah, I can tell by your haircut, Jesse.
No, that's just I'm lazy.
Yeah.
I need to lop it off. But then there's people like you.
Need to go. Yeah.
All right. Anyway, so this diagram. Am I showing the diagram or Stellarium?
Yes.
Diagram.
Okay. Good.
The diagram. Yeah.
Okay. Good. This shows how it's possible, and in fact required, or unavoidable, that their method would give flat Earth results in the case of Mount Rosa. So the apparent angle is 132.20, as you can see here in the right bottom corner. So that's represented by this curved line over the top of the mountain to the star. which is shown closer for detail than it would obviously naturally be. And so then they turn off astronomic refraction. So that drops the angle down. So like if you went to this location in time and into stellarium right now, these are the same numbers you would see. And that's in fact what he did. So when he turns off astronomic refraction, that drops it down to 1 degree, 16 minutes, 51 seconds. Well, obviously that's too low. See, it cuts, that's a lower elevation angle than even the flat Earth prediction of this mountain. So then he moves stellarium to the mountain peak. Well, I did the math, and it's 29.65 miles away, which equates to 25.765 nautical miles, which equates to 25 arc minutes and 46 arc seconds. So remember, we have this true angle down here. If we take that true angle, which I've replicated up here, and add that 1 degree per 60 nautical miles, look what we get. 1 degree, 42 arc seconds, or minutes, and 37 arc seconds. I guess I had a rounding error. There's 1 arc second off, but it's basically the exact same angle that you get
Oh, man.
for the flat Earth prediction. So in other words, at this
that is because of the distance and delta height combination.
Right, the amount of the astronomic refraction when subtracted, and then the addition of 1 degree per 60 nautical miles made it match the arctangent of the rise over the run, spot on. So that's exactly the number that you would expect on a globe. So
if you did the why would you do it method of turning off refraction and moving the observer to a different location.
Right.
Yeah.
I don't know if anyone should tell them the secret, but all they need to do to really fudge factor is, instead of moving stellarium to the mountain peak, just move it however far is needed to make it match.
That's even better. Yeah.
But
somebody should tell them that. All you need, instead of, the fudge factor of putting it at the top of the mountain, what a pain in the butt if it doesn't give you the answer that they need.
Yeah. So then Dr. Heffron started looking for ways to save it. See, do I have a right, left?
Here we go.
Save
their method.
Save their method.
Yeah.
And so he started, the next thing I know, he's saying, well, there's a timing error in stellarium, and the azimuth angle given by stellarium for the star is wrong. And so he says all he has to do is then adjust the time in stellarium until the azimuth angle indicated matches the true bearing from the observer to the target location where the star occluded, and then he said everything is good.
So can I interrupt for a second? This whole procedure is based on the time that you observe something, right? That's exactly. The measurement is the time that the thing occludes, and the fudge factor is to change the frickin' time.
Oh. Right. Yeah.
But he says, wait, did he say there's an error in stellarium?
Yes, he said there's a timing error in stellarium.
Did he just say that, or did he have something to back that up?
Well, no, he said it. And so here's what he did. And this he did for Greenhorn Mountain, which he called North Peak in his later spreadsheets. And so what he did was, here's kind of an overlay of, let's see. So this is actually the slanted, his C-star camera was not level. That's why this is slanted. I had to rotate it to line up the stars. And so the faint star back here is stellarium showing through, and then the bright one is his filmed star. And then this thick red jaggedy line is from where I traced out his horizon before it got too dark to see the horizon line on the mountain. And there's two of them because he then later lowered raised the C-star to get a flashing light out of frame because it was messing it up. So what he did then was he said, well, there's a timing error and I have to adjust the azimuth, or I have to adjust the time until the azimuth matches. And in this case, he claims that this little bump here was North Peak.
Okay.
But see, North Peak is, I don't know if you can see that. North Peak is over here.
Oh.
This is Greenhorn Mountain Peak, main peak itself. I call it the South Peak because it's opposite the North Peak. But his camera is only a 44 arc minute wide field of view, and it's a degree between this peak here and this peak here. So, but he thought that, well, he claims he thought, he might have. But I would have hoped he could have checked himself a little. But anyway, he thought that this was North Peak here, or just right off the screen. So he thought, well, this star should have an azimuth to the farther to the right of this or something. I'm not sure how he arrived at it, but he ultimately ended up saying
he thought that low point was a peak.
Well, he thought, because see,
it starts to go up a little bit.
So he either thought this was North Peak,
okay,
which wouldn't have made sense because there's nothing to the right of North Peak, or he thought this was just the edge of North Peak right there.
Okay.
But it wasn't, as there's a bump in the middle, halfway between. And I mean, and I sent him all this information. I sent him screenshots way early on. He just ignored them. So anyway, so what he ended up doing was saying, well, there's a timing error of over 3 minutes in Stellarium for this particular measurement. So I'm going to have to, he said, adjust the azimuth by a whole bunch.
Wait,
and so he actually adjusted the time.
A 3 minute error in Stellarium, he said?
More than 3. Yeah, 3.
3 minutes of time. 3 minutes of time.
Right.
So, but if there's 3 minutes of time error in Stellarium, would nobody have noticed this yet?
And it would destroy, like he's using it to prove his point, right?
Yeah.
If there's that much error in Stellarium, you can't use it.
Right. Yeah, you need to find a new method if you don't have a good method. But what he ended up doing was, so here's IPUP, the star IPUP. This is where he filmed it, and we know this is where he filmed it because this skyline is what I traced from his own video, the same video that he filmed it, setting right here before it got too dark to trace the mountain skyline. And you can actually match this skyline up on Google Earth, and this, it all checks out. This is where it was. It was not over here, but he adjusted the azimuth of, or he adjusted the time in Stellarium until the azimuth of the star was all the way over here, which, because it's coming down, he's in the northern hemisphere, so
yeah,
it's coming down at an angle, so that moved it from here to about here. Of course, it's hidden behind the mountain now, but that removed the 2,000 feet that he didn't like, the extra 2,000 feet, and he just said, well, it was just this huge error, and now it's right, and everything's golden. But he didn't bother to check to find out that that put the azimuth of the star way outside the frame of the camera. So if that's where it had actually set, which is what he's claiming, is it actually physically set at this location, at this angle, he wouldn't even filmed it. But he did film it.
It was off screen. If his claim was true, it would have been off screen.
Yeah. And so I went into Google Earth and found the exact spot where this little bump goes down and the next bump goes up, and because that star kind of occluded right in that little valley, which really pinpoints geographically where it occluded.
Yeah.
And you can find that on Google Earth, and I found that on Google Earth. And then I used a geodetic grade bearing calculator to get the bearing between the Dr. Mike's house and this point where it actually occluded, and that's the 200 degrees, 45 minutes, and 12 seconds. Stellarium, at the time that Mike recorded it having occluded, was 200 degrees, 44 minutes, and 51 seconds. That's like, or 52 seconds. That's like 44.
Yeah.
That's like what, 25 arc seconds or something. So that's like
20, yeah.
yeah, it's like really close. So in other words, if Dr. Heffron had actually figured out where the star really occluded and calculated the bearing to that point, it would have matched the azimuth given by Stellarium within the margin of uncertainty, completely within the margin of uncertainty. And another mistake that Dr. Heffron made is when he was calculating the bearings to stars, he was using some website called Movable Types or something. They've got a bunch of super handy little online calculators. It's nice, but it uses pure Habersign, pure spherical geometry, no geoidal geometry or ellipsoid.
Just go back one step. Yes, they are using a sphere-based formula to calculate distances, but it's based on a perfect sphere and not an ellipsoid geoid.
Right. So there was.
Yeah, I don't want the point to be missed. They're using the sphere everywhere.
Yeah. They're using the sphere everywhere. But initially, he was using an azimuth calculator that gave up to like 6 or 10 arc minutes of error, depending on the situation, because it was assuming a perfect sphere, not a geoid. And so he was trying to use that also as a fudge factor. And so then I gave him a better calculator from Ruhif, who gave me the link, but it's actually from NOAA, NOOA, the weather people.
Yeah.
The mapping section of the weather people. And that's what I used to calculate this 24512. So when I did a few spot samples and showed him that using, just correcting using the azimuth actually doesn't change anything much if you use the correct azimuth calculator, one that actually gives the right result. So then he came up with a new correction formula, or a new correction method, which I don't have a slideshow for, but this was, as far as I can tell, his new correction method. They tell me I'm misrepresenting him, but nobody will tell me the right way. And when I look in his spreadsheet, this is the math. So this is what they're doing. Even if they think I'm misrepresenting what they do, this is what's in their spreadsheet. Actually, should I bring up their spreadsheet? You want to talk for a minute, Ruhif, while I bring up their spreadsheet?
Sure. Like I said, their main sin is using Stellarium, which is a globe piece of software. Like you move forward a degree of latitude or longitude towards a star, it raises by 1 degree. That's a sphere. They use Habersign for getting distances. To calculate this fudge factor, like I said, they use the right ascension declination of a star and then use sphere geometry to work out the azimuth and altitude of it. It's comical. The whole thing's comical.
Okay, is my spreadsheet up?
Yeah, I see the spreadsheet.
Yes.
Okay, so this is actually my Google Docs copy of Dr. Heffron's prior Excel sheet. And it's the one I'd messed with, and I understood it more because he just recently released the other one. But this shows how they were doing their timing correction. So basically, he's got a tab. He's got like 4 tabs here. This is angles get retrieved from Stellarium with Stellarium placed at the peak. And this is for angles retrieved from Stellarium with Stellarium placed at the observer location, both with atmosphere turned off. And then this is his slam dunk graph that shows the errors between the predictions and the measurements. You can ignore the red and the magenta. I'm not sure what kind of straw manning of the globe prediction he was doing there. But the important thing here is the green line, which is showing perfect match between his measurements after being corrected and the flat Earth prediction. So
this is the newest sharpshooter application that he put in.
Savage
Yeah.
sharpshooter, yes.
I've got
Yeah.
the sharpshooter fallacy card up right here
Yeah.
that I pulled out for him.
Okay, so this is his method. First, he puts this was his newest correction method before he had to abandon it, and now he's trying to come up with a third, but he hasn't told me what it is yet. They like the element of surprise, although Alan has been trying to get me some information on what's going on ahead of time before the show. So I got to give him kudos for that. He was sending me spreadsheets and then in the end, Steven sending me some about the method. But anyway, this is the method. They've got... All right, so here's the time, which he calculates from the start time of his C-star video sequence and then the frame offset. So that's okay. So this is the actual time of occlusion here.
Okay.
Hang on, is that an adjusted time? That's an
What's that?
adjusted time, right? That's an adjusted time.
No, that's the actual time. We don't see the adjusted time here because
They've got E4 in the end, right? E4 plus E4 in the end of it.
do they? Oh yes, I'm sorry. That is the adjusted time. Okay. I'm sorry. So this is the adjusted time. They don't display the unadjusted time, but the E column here
Is this,
has the number of seconds that they fudged it.
This is a fudge
This
column?
is the fudge factor.
Yep.
They just add the value necessary to get the results that they require?
Like I said, this whole thing is based, the only measurement they make is the time that it occludes, and then they go and fudge it. Like it's
Oh
it's
gosh.
insane.
Yeah, so let's see if I can remember where the... Is this it? Yeah, this is it, I think. So what they do is, so you can see they have the distance here and the... Where's the height? Observer. Oh, observer height, distance, and official altitude here. So from that, in one of these, which one is it? The arc. One of these is the arc tangent. They take the arc tangent of that to get. Oh, maybe it's right here. I think this is it.
Yeah, see, this is what I had to clean up in Heffron's spreadsheet, is to actually give them names,
Yeah.
right, rather than O2 and R4 and G3.
Oh, they
Like,
did. Oh, jeez.
All right. So
They can't
look at
even
what
name
they're-
the column? Come on.
Yeah,
So look at what they're doing. Is my font readable, or is it all just too tiny?
I can see it.
That
Yeah.
looks fine, yeah.
Oh, okay, good. All right. So here they're taking the arc tangent of. So Q2 is.
O2? O2.
Let's say, O2 is, what is O2? Oh, O2 is
That's
simply,
the delta height?
that's simply the delta height. Yeah, delta height of the mountain. So O2 is just the delta height of the mountain. So that's just the rise. So O2 is the rise. So they're taking the rise. Now they're subtracting two times R4. Now R4.
Why double?
Well, because it turns out that double globe drop is almost exactly 1 degree per 60 nautical miles.
Wait, that D squared over 2R, is that R the radius of the globe?
Yeah, so if you take the distance to the mountain, square it, and then divide that by 2 radius of the globe, that gives you the drop over that.
This is their process that where they conclude
no.
therefore flat?
No,
This is a globe prediction. Yeah.
yeah,
okay.
this is just the metric version of 8 inches per mile squared.
Okay.
Yeah, this column, is just the metric version of 8 inches per mile squared. So at a distance of 50.6 kilometers, you would have 201 meters drop from the horizontal. So that part is legitimate.
Okay.
But what they're doing here is they are taking the arctangent of the rise minus 2 times the globe drop,
Oh,
which makes that equal to,
for unknown reason.
well, they claim he came up with this convoluted story that he told that no one really understood, that because there's the mountain and there's the observer and the globe, and they both, and an observer on both points would both have globe drop looking the other way, so therefore you should put in 2 globe drops. And so
What? If you had 2 observers?
it's something goofy. I don't remember exactly.
Okay.
I don't know. No one else understood it either, but he was going through his presentation and it was something like that. He did give a verbal rationalization or ritualization of of why he used 2 globe drops and called that a perfect globe prediction. I see your mitt up there. Is that the fireproof one?
Oh, it's
Yeah,
the
so just to be clear, it
FTFE
should
one.
be 1 globe drop to get a
Globe
raw elevation angle.
Right. The unrefracted geometric globe elevation angle to the mountain should be the rise minus 1 globe drop divided by the run. But he put 2 globe drops minus 2 globe drops divided by the run, because that is equal to 1 degree per 60 nautical miles. So what he's doing is he's creating an angle here, which is flat Earth prediction minus 1 degree per 60 nautical miles, which is what 2 globe drops is. So
Yeah, I think you're right. Yeah, I have to check that, but yeah, I think so.
I got a spreadsheet. I did a comparison. I calculated globe drop using full sine cosine trig, and then 8 inches per mile squared, and 1 degree per 60 nautical miles, and d squared over 2r, and it tracks.
Okay.
It is. It's spot on. So, or very, very, very close. I mean, obviously, d squared is a parabola, not a circle. So it's not perfect. It's just like the 8 inches per mile squared. It's not perfect, but it's close within, 100 miles. So, anyway, at these distances, it's a legitimate approximation, and it's simpler than the full trig to calculate the actual globe drop. So, but what this J-column header field is flat Earth prediction minus 1 degree per 60 nautical miles. And see, this is done at observer location with the atmosphere turned off. So his first step, and he calls this the perfect globe prediction, which it's not, because as we explained, it's double globe drop, not single globe drop. Anyway, so his first step of this correction, his then third correct, or his second correction method, and most recent published correction method, was to, at the observer, with stellarium at the observer, calculate the flat Earth prediction minus 1 degree per 60 nautical miles. So then, what? Yeah, well, tiny globe.
Yeah.
A half diameter globe.
Okay.
But the key point is that it's minus 1 degree per 60 nautical miles to the mountain, because the next step is to then move stellarium forward to the mountain, and he needs to have already subtracted 1 degree per 60 nautical miles, so that when he adds it back in, and from moving stellarium to the peak, then he ends up with the perfect flat Earth angle. So then he converts.
He must know this is bullshit, by the way. He must.
Yeah.
So then he converts. I wonder if I can make this bigger.
Yeah.
Oh, I did.
That DMS formula is giving me conniptions.
Don't look at it. Anyway,
What in the-
so
Having massively long formulas in a cell.
Oh,
just, it's an ick.
As a programmer, I hate that. That's Perl. It's so Perl.
Oh, Jesse's going to take that personally.
Oh, gosh. Wait, Jesse, do you like Perl?
I love it.
He does.
Oh.
But you can write functions in Perl.
Just a second.
Yeah, I remember back at uni that the acronym was pathologically eclectic rubbish lister.
Yes.
And I thought that was pretty accurate.
It does do that. But anyway, so he calculates this flat Earth prediction minus 1 degree per 60 nautical miles. He converts that to degrees, minutes, seconds. Then he takes and goes into Stellarium and adjusts the time in Stellarium until the indicated elevation angle is 231.50 in this, or it is, I'd say, 231.50. So that's his target, his set point. Then however many
Hang on, does he adjust the azimuth or the elevation angle?
Well, you can't adjust the azimuth except by adjusting.
Oh, no, but like until it hits some
Well, this correction
arbitrary value.
in his first correction method, he adjusted the time in order to achieve the desired azimuth.
Okay.
But when I pointed out to him that didn't work on several important points that he had not tested it on, he then came back with this second method, which ignored the azimuth and simply used this prediction of, or this angle of flat Earth minus 1 degree per 60 nautical miles.
Wow.
And so then he would simply adjust the time in Stellarium until the indicated elevation angle or altitude angle of the star matched this say in this column 2350, 2 degrees 3 minutes 50 seconds. Then however many
if that's true, I don't even know what to say about that.
It is. That's how he got such an incredibly straight green line.
This is anybody that's ever done any measurements knows if you get a perfect number over and over and over from different measurements, something's not right, because that doesn't happen in meat space.
Yeah.
It's never perfect. If something seems perfect, it's wrong.
Oh, what I think, so there's a column to the right saying how much it's off by in terms of meters, and it's like, half a meter, 1 meter. Keep going to the right. Hang on, no, on the peak one, sorry. So he's perfect. Straight line. Sorry, I'm
almost getting there.
Okay, all right.
Yeah, I'm almost getting there. So at this point in this correction process, you can see he's got these all tuned in until the indicated elevation angle is very close to 230.50. And you can see he's done it individually. He didn't, just take an average and apply the same offset to all of them. He's done it individually to every single one. 16, 18, 13 seconds, 16, 18, 14, 12, 10, 14, 20, 16. He's adjusted each and every one of these to the exact seconds needed to make that data point match, even eliminating noise.
This is his data.
Yes.
This column you didn't put in there. He put this column in there.
Yes.
Oh my gosh.
The only thing I did here was I put in a new theoretical data point down here, which I'll get to in a couple minutes because it's pretty exciting too. So once he's got Stellarium set to this angle, now remember, this angle is not the flat Earth prediction, because he doesn't want us to know that he's just preloading it to give a flat Earth result. So that's why he's
trying to obfuscate it through a couple of layers.
Right.
Yeah.
So he puts it at observer location, puts it at the flat Earth angle minus 1 degree per 60 nautical miles. Then all he's got to do is move it to the target location that adds back in the 1 degree per 60 nautical miles. And as I told him, any numeric value for x minus x is always 0.
Wow.
And so he's literally...
I asked Alan this morning, what is the justification for this J column, the timing offset? He hasn't got back to me yet. So.
Oh my gosh.
Yeah, so here, now you can see, here's our 2 minutes 31, or 2 degrees 31 arc minutes, because now he's added back in that 1 degree per 60 nautical miles that he subtracted earlier from the flat Earth prediction. So this J column here is just the flat Earth prediction. And the original time of measurement has no influence on the ultimate result because he simply adjusts the time however much is needed in order to make it match the flat Earth angle, just with that little plus and minus step in there.
And the issue is, like, Heffron, it's so hard. Like, he may legitimately have a PhD in computing science, right? I find it difficult to get in contact with him. And he's been gatekept by idiots, obviously.
Oh, yeah.
I don't know how they come back from being shown that X equals X. Yeah, I'm a bit stunned. Sorry.
That's all right. So to test the theory, I went into Stellarium. Oh, let me shrink that back so I went into Stellarium, and you don't have to see all the stuff on here. Anyone who wants the spreadsheet, I can just share it. Actually, it's probably public. Yeah, it's public, and it's on my public email, so I can share that with anyone who wants it. I have a special email account for this that I don't mind sharing with people. So anyway, I says, well, let's say there was a cloud bank over Mount Rosa. Now, Mount Rosa's, I picked it because it's the one that matched flat Earth perfectly, without any corrections, just using their method, it matched flat Earth perfectly because it was in the spot.
In the sweet spot, yeah. Right.
Yeah. And so I says, okay, what if there was a cloud up above that and it caused the star to occlude a whole lot earlier, like I think 20 minutes or something, I don't remember. And would his correction seamlessly correct for that? That was my question. So I got the time. I set it all up with the observer at his house and got the date and time for the star and the star name. And I inserted that star right here. So this is not an actual occlusion. This is just simulated from Stellarium if there was a cloud at that certain location. And I followed his exact procedure. I went into observer location. Here it is. I highlighted it in yellow. And I adjusted Stellarium until the indicated altitude angle matched his little flat Earth minus 1 degree per 60 nautical miles. I put in the correction seconds, 1,320 seconds of correction. And I put it all in and went and I copied that 1,320 seconds to the peak location, put that new time into Stellarium at the observer location, and it was 2.3 meters off. So we can go now to the graph, and you'll see even with like a 4 degree of elevation error in the reading, 1,600 seconds of time error, his green line is still flat, perfectly flat line.
Self-correcting.
Yeah. Now, and I can prove that I actually did. That data point actually is in this here by simply going to here, and I'm just going to change the elevation angle field here. I'm just going to add on, 1 to the front. And now I go to graph, and now there's a huge spike.
Uh-huh.
So I really did it. It really is influencing it. But his correction method simply fixes anything and everything. So
that's so handy.
Yeah, it's like, so I told him, you guys don't even need to go measure anything anymore. All you got to do is just use your spreadsheet and claim flat Earth, assume flat Earth, and claim flat Earth. You're not, the measurement no longer has any influence on the outcome. And just for fun, I made.
If you guys are listening, Alan, Shane, I don't even know what to say to you guys.
The stink of desperation.
Yeah, it's getting pretty bad.
Let's see. Oh, here we go. I just found it. I'm gonna share a different screen here. Are we running short on time, or what are we up to like?
We got open-ended here.
Okay. All right, let me switch windows. Okay, new share.
We've got a concaver in the chat that comments, research concave Earth, as if we haven't. Of course we have. I look up at night, I don't see Australia lit up, Ruhif. Right now, I go outside, I don't see you. I researched concave Earth.
Yeah, shine a really bright light down, or I mean up. I want to see if I could look up and see it. That would sure make a difference for wireless communications, wouldn't it?
Oh my goodness, yeah.
Okay, so just for kicks, I thought, well, if he can assume a flat Earth and get flat Earth results and call it a measurement, why can't I assume a globe Earth and do the same old thing? So I took all the star measurement data points in my spreadsheet, and here I have the actual time column. And since he named his fudge factor column J after me, he literally said that.
He did?
Yep.
He named his fudge factor after you. Aw.
Yeah, yeah.
Facetious, right? Sure.
I think he's got to be, yeah. But anyway, so I named my fudge factor column the Heffron value, time correction in seconds. And then here I actually show my corrected time as well. And then, so what I did over here is I do the same thing as him. I take and calculate 2 times d squared over 2r, so double globe drop. I convert that to degrees with arctangent. And then let's see, what's this? I take the predicted globe Earth angle minus, because he took the predicted flat Earth angle minus 2 globe drops. So I took the predicted globe Earth angle minus 2 globe drops. And see, how do you like this, Ruhif? Instead of that wonderful long formula that
Approve.
That he was
Although
using.
You still haven't named your cells though. Still got O2 and T2. Come on, champ.
Oh yeah, but look at least instead of that long formula to convert to decimal degrees or DMS or whatever, I just call my little JavaScript function DD to DMS.
That's so much. That is much better.
Criticism retracted. I'll give it a look.
Yeah. Anyway, so I create the globe predicted angle minus 2 globe drops at the observer location. And then I move it forward.
Go and move it to the peak.
Yep, and then I move it to the peak. And here you can see my error on the globe prediction is like 0, minus 0.2, minus 0.3.
Well
and then
done, Jesse.
Yeah, and so if I go somewhere here, I have a graph. Mine wasn't quite as well organized as his, but oh, there it is. So you can see, for the most of it here, the globe delta is 0 basically, and then the flat Earth is all over the place.
But Jesse, you're gonna have to cherry pick better. You got to.
Yeah, I know.
Heffron cherry picked much better than you.
Yeah. Well, so what I did was just for control, just to demonstrate that I'm doing all the math right. I took the last 5 entries and repeated them, but for them instead I used the flat Earth prediction minus, and so I used the flat Earth prediction instead of the globe Earth prediction. And so you can see that for those, I got perfect flat Earth match.
Oh, that's why. All right.
Yeah. So I'm demonstrating that with his method, you can, if you want to predict a flat Earth, you get flat Earth results. If you want to predict a globe, you get globe Earth results. So that was just something I kind of did for fun.
Nice. That's why the red line then is right in on the
Right.
what is that?
Yeah,
Zero.
that's-
Yeah, zero error when you
Right.
use the
'cause that's-
Heffron method to assume flat.
Right. So, because just for control, let's test it with the flat Earth assumption, and in that case, my my prediction was based on the flat Earth instead of the globe Earth. So, I'm just showing that with his method, you can predict globe Earth and get globe Earth, or you can predict flat Earth and get flat Earth, and so it's not even a measurement; it's just obfuscation or something to make it look like a measurement when it's just your prediction.
Yeah.
Got him.
I did. I got that mosquito.
Oh, wow.
That's nuts.
Yes.
What was my message to you this morning, Jesse?
Oh,
What
I
did I
don't.
say?
You said something about. Let's see.
Oh, holy F, this is going to be comical, isn't it? I'm looking at this timing offset.
Yeah. Yeah.
Yeah, sorry.
Yep.
Okay.
So at this point, that pretty much brings us up to the present. We did have a celestial theodolite Earth of Whatnums, and they kind of let me talk, but as soon as I would lay some basic foundational questions, I like, well, do we agree that when we even on a globe Earth, if we move forward 60 nautical miles, the star will appear 1 degree higher? Yes, we all agree. Okay, and I get over a few basic things like that, and then when I get to the key question, all the Aether boys jump in and won't let me ask it, and won't let Dr. Heffron answer it, and he doesn't want to answer it. And so it's kind of this trick. They act like they're letting the other side speak, but then cutting him off at the very last minute. So he gets airtime, but he doesn't get to cash in on it. Does that make sense?
Oh yeah.
Yeah. Oh yeah, they did let you speak, Jesse. They did let you speak.
Yeah, they did let me speak. They wouldn't let Whip speak much at all.
Yeah, I got muted 3 or 4 times by Alan. So Jesse was interacting with Heffron for, I don't know, probably an hour on this whole azimuth and elevation shifting correction rubbish, right? And my simple question was to Alan Shane Heffron, is there an observation that contradicts the globe prediction? And made it clear that our globe prediction doesn't include stupid shit like teleporting the observer and pretending we live in a vacuum, right? So I said, is there a observation that contradicts the globe? And they go, yes, all of them do. And I had to go through them, saying, here's the canonical original Pikes Peak one. Here's the globe prediction, the non-strawman globe prediction. And here's the calculations that match it. No, sorry, here's the observation that matches it. So that's not a contradiction. Show me one that doesn't match. And I got muted, probably 3 or 4 times. And Alan's not very happy with me at the moment. So anyway.
So I tried to get to the bottom of, you've got a little liquor there.
I got a
I tried to get to the bottom of the timing, the invalidity of just adjusting the time to match your desired angle. And so when they all realized that was not going well for him, then they switched to saying, well, no, we're actually doing it based on the azimuth. And so then we started diving into the azimuth, and I'm trying to tell, and I didn't have this slide ready.
Yeah, it's off frame if it's azimuth.
Yeah, I didn't have this slide ready at the time. I knew that they had done a 3+ minute correction, and I went into Stellarium and I says, look, and they let me share my screen. I said, look, it occluded here. You're saying that it was 3 minutes off. That puts it either over here or over here. And so then they're like, well, you just picked out the one bad data sample. It's like, no, you did the same time to all the stars on that mountain. They're all going to be off by that much. And when they realized that wasn't going well, then they then they doubled back to the time offset, or then they started saying, well, but the arctan of the rise over the run minus double globe drop is the ideal perfect globe. That's the right way to do it. So it's like they had these two corrections, and as soon as we get to the bottom of why one's bad, they divert back over and start fresh on the other, only to divert just like hopscotch back and forth just to keep from ever getting to the bottom of either of them. So at this point, the celestial theodolite is in utter shambles, and they are trying to figure out how to save it as we speak.
Well, yeah. Yesterday, I think Shame Saint Plagiaire posted on Facebook something about how awesome he thought this celestial theodolite was, and of course the minions on that thread are like, yeah, but of course none of them know what the method is. Except
exactly.
Probably just
Whitsitt does not know the method.
No, it's probably
he
just
brought it up as one of his top proofs in that debate with Jaron.
Yeah, it's probably Heffron and Alan are the only two that actually know what the method is doing. I don't
Alan
know.
doesn't either.
No, he does not.
Heffron is the only one, because everyone tells me, Jesse, you're doing it wrong. You're misrepresenting him. You're not doing the steps right. I'm like, okay, what are the steps? I'm like, well, we don't know. You'll have to ask him. I'm like, I did ask him. He's not telling me. And so,
okay, so Alan doesn't even know. I mean, Alan sometimes tries to do math, and so I thought maybe he was trying, but I guess not. Okay.
Yeah. So Alan was like, so I'm like, well, look, if we can't just trust Heffron like Globers trust NASA, that's seemed how I thought they would relate to that. And not a single flat earther knows how to do this correction. And you're saying I'm doing it wrong. You need to help me, figure out. And he's like, okay. So he hooked me up with, he started a group chat with Piezo, Etheric, whatever, the Crystal Wizard, I guess he goes by on in their little cosplay thing on the Aether Cosmology show. And I asked him, and he's like, you'll have to ask Heffron. So it's like not one of them. And Aether Piezo does know basic math. He can do trig. I've seen him do it live on stream, so I know he can do it, but he did not know how to describe the step-by-step procedure either. So I think it's safe to say that not one of them other than Dr. Heffron knows how to do it.
Right. But now, if for the people following along, they know how, and they can rewatch you running through it step by step. And Ruhif, you had a really good video. Was it 2 days ago?
Yeah.
Going over it. Very nice video there.
I do have a special treat for the famed Shane.
Ooh. Remember, on this channel.
Shame.
Yeah.
Yes.
Shame Saint Plagiaire.
There you go.
So he came up with I don't know, someone came up with this, but he was haranguing me about it or whatever. And so I added in a bunch of yellow text. He was trying to say that if the star had occluded Pike's Peak at some other time, whatever, but it didn't, so flat Earth, So I switched it around because now we've got other stars that match the globe Earth. So this Edith hooked to Blinn Mountain, the star HD 187633, on this date and time at this time zone, it occluded Blinn Mountain as if, using their method matching the globe. So just for you there, Mr. Shamley.
Wow. Yeah. they can't claim that it matches even remotely because you have done that measurement.
Yeah.
And none of them went to that spot and remeasured. And when you've asked them to do measurements of to Pikes Peak or whatever from a different location, they absolutely refuse.
Yeah, that was strange. And
I think it's
I think
very,
it shows
very
it-
telling.
I think it was very telling of a couple things. One, that Dr. Mike knows he's not being fully forthcoming with the accuracy of, the dependability of his method, but it also shows a lack of awareness, because if he was just trying to avoid it, he could have says, "Oh yeah, I want to do that. I'm just busy. I haven't had a chance to do it yet." And internally, he's like, "I'm never doing that." But he could have said something to at least not make it look like he was cherry picking. But he didn't have the awareness to do that, and he just straight up said no.
What was the name of his book? The Ramblings of an Old Man About the Scientific Method or something?
Yep. The Ramblings of an Old Man About the Scientific Method.
Yeah, there seems to be a lot of, refutation of the null hypothesis and all that sort of, it feels a little bit, what's the word? It's like, professors, if they saw a 3 sigma result or a 5 sigma result, he's trying to put on an air of this is proven, basically.
Yeah.
When it should just come down to this either supports a hypothesis or it falsifies it. And I think there's a lot of, outside of the actual celestial theodolite, there's a lot of talk about this scientific, I don't want to say mumbo jumbo, but it's, do you know what I mean? Like he's putting on airs of this great scientific method, and it's.
Oh yeah, he wrote a whole book on the scientific method. Therefore, he's an expert.
He is
like Feynman. Feynman said, if it disagrees with experiment, it's wrong. That's the fundamental of science. That's all it had to be.
Yeah.
Anyway, sorry, Jesse, go.
Oh, I was just gonna say, Dr. Heffron is very pleased with himself. He was actually responding to some of my emails, but not answering my questions. I'd, make very simple, pointed questions, and he would respond.
Is his email address Dr. Heffron via Allen at gmail.com?
No, just
Alan,
I was emailing him.
Alan allowed you to send him a direct email without being in the middle. Wow.
Yeah.
Wow.
He has not responded to any of my emails. So
A lot of times he doesn't respond to mine, but sometimes he does.
okay.
There you go.
But when he responds, it's like he'll go on for like a full page about his experience with the automotive industry and his patents and like all this different stuff, but he doesn't answer the question I actually asked.
In my day, we used to we had a yellow onion on our waistband because that was the thing of the day.
Nice.
I wish I could quote that better. Darn it.
What's that from?
Simpson. Grandpa Simpson.
Oh,
Yeah. Go on, Jesse.
Hold on. The onion story. I'll get it. Hold on.
Yeah, DP debunks. Old man yells at sky is the accompanying newspaper article.
I have seen the old man yells at sky meme posted around Discord.
All right, there you go.
Was I going to screen share something?
Like the time I caught the ferry over to Shelbyville. I needed a new heel for my shoe, so I decided to go to Morganville, which is what they call Shelbyville in those days. So I tied an onion to my belt, which was the style at the time. So to take the ferry cost a nickel, and in those days, nickels has pictures of bumblebees on them. Give me 5 bees for a quarter, you'd say. Now where were we? Oh yeah, the important thing was I had an onion on my belt, which was the style at the time. They didn't have white onions because of the war. The only thing you could was the yellow ones.
That's gold. Ion, is it Ion in the chat? Yeah, Ion says he thinks I was going to plan to screen share something early in the stream. I've just chucked it up.
Great.
All right, yeah, you can share now.
Yeah, let me unshare.
Yeah.
Stop share.
All right, my application window. That work?
It's coming.
Something.
There you go.
There we go. Oh, I love this one.
Yeah, so Jesse had already, before I made this video, Jesse had already figured out the relationship between the distance and the delta height, as in what combination gives you a good celestial theodolite result. This magnificent graph here kind of demonstrates that relationship. So on the x-axis is the distance to the peak, and the y-axis is the delta height, so the difference between your observer height and the peak height. And if you fall on that white line, you get a good celestial theodolite result. If you fall up in the purple, you get a shit result. That's all I wanted to share. But yeah, like as we've been through, it's the combination. I'm not going to say Heffron cherry-picked his combinations, because I don't think he did. But it just so happens that some mountains give better results than others without all that correction rubbish.
I get the impression that he stumbled onto it, that like he did it the first time, and then he's like, "Oh, look! If I use this ridiculous method that nobody would ever use, but for some reason it works. Therefore, I'm just gonna dig in. I'm gonna put my heels in. And I'm gonna assume it works." And then he's generally the same distance from those other mountains, right? I mean, he's not a lot.
There's a cutoff. So none of them are closer than like the 22 point something mile one, which was, using his method, came right in between flat and globe, slightly closer to globe. So yeah, his house is at a distance where none of the mountains he could get occlusions from would have actually gone much closer than halfway to globe.
Yeah, and
the farthest one,
and that's the geography of Colorado. There's a line of mountains.
Yeah.
And he is a certain distance away from that line. So all of the mountains that he sees from his house are within a certain narrow range of distance from him.
Right.
Yeah, like I said, I don't think he cherry-picked his observations, but I think his first one happened to get reasonably close to his crazy idea that he explored it further.
But he did start cherry-picking the moment we asked him to get a little closer to Blodgett Peak.
He said no.
Because as soon as I figured out the formula that modeled his results, I found a couple public park places where he should be able to get the right distance from Blodgett Peak to get a globe Earth result. And I asked him to go there and do that, and he would not.
No.
He definitely would not. So at that point, he did begin cherry picking. But it didn't matter, because then I went and got globe results, and now Shane and another flat earther have both submitted, or I'm sorry, Alan and another flat earther have both submitted globe results from their star sightings.
Globe
so Alan
results.
did in other words, using the Heffron method without any crazy corrections. Alan did a star occlusion timing, and it's closer to globe.
Oh, oopsie.
And there's another flat earther who is part of their team that also did a star occlusion timing, and it was spot on for globe, just by the chance of where he was.
Is that the Houndstooth one?
No, Houndstooth would have been Alan's. The other one, yeah, the other one was, let's see. I have so many windows open, and each one has so many tabs open.
Yeah, you need everybody. Make sure you get your tabs going.
Yeah.
I'm out of Red Bull. No good.
I just because it's red doesn't make it a tab.
Yeah. It's not actually Red Bull. It's the Australian equivalent called V.
Ah,
it's better than Red Bull.
Oh, V Bull. Okay.
How do you know it's better? Have you had Red Bull?
Tastes better. Yeah, we've got Red Bull as well, and it's okay, but V's better.
But is it better than Foster's, which is Australian for beer?
Oh, first of all, as an adult, I have never had a legal beer as an adult.
What?
My beer drinking ended. My beer drinking ended at 16. Yeah, Scotch all the way now.
Oh, all right. I got some.
Yeah.
Right here.
Beer is filth. What is that?
Crown Royal.
Oh.
I'm not a big fan of well, I don't know much. There you go.
Just your reused tab cans.
The tab, yeah, that big time.
So one interesting thing, and I've been bugging them about this ever since I figured out the formula that modeled it, is to say to them, don't you think you should stop and reassess things if your results match this formula of globe apparent angle minus astronomic refraction plus 1 degree per 60 nautical miles? Because it's one thing if they're saying, well, we're having errors that we can't really explain, but they're not unexplained errors when they match a formula, are they? But they never really seem to take that to heart very well.
Well, yeah, they've committed to this.
Yeah.
But you really think about this. They have stated things about this, definitively.
Yeah.
Shame on his Facebook post. Let me bring it up. Let me see if I can find it.
I almost had a doggy in here.
Oh, yours are cute little doggies, I remember.
Yeah. I'll try and get her. 1 sec.
Yesterday, Shame said it's simple, easy, and repeatable, and a good part of the community is challenging the globe with these measurements. Alan added the collective data himself 3 nights ago, meaning this is a community project with collective data and repeatable results that are mutually exclusive between the models. Mutually
May
exclusive.
I interrupt that? When he says mutually exclusive, what he's doing is strawmanning the globe, saying, I'm going to use the celestial theodolite bullshit to make a prediction for the globe. And I've told him several times we're not doing stupid shit like teleporting the observer and turning off the atmosphere. Our globe prediction is, the distance, delta height, minus the drop, plus refraction. That's it.
Okay, now
And he keeps trying to hold us to this celestial theodolite as a valid method.
so I listen to how boldly he has proclaimed this. Turns out this is becoming the #1 flat earth evidence. It is 100% unrefuted by any globular proponent, though you just did here, Jesse.
Oh, scroll down. That's his tweet from yesterday, right? Scroll down.
This was on Facebook, yeah.
Okay.
The data is irrefutable. So, he's committed, 100% committed to this. The blue line is the flat earth prediction. Notice how tiny the variance is. This is when this is when applying. Can you pull up the graph, Rufus?
The fudge factor you got it on the screen now, haven't you?
Oh yeah, that's
the column D. It's not column D. Sorry,
It's column.
Where's the J?
Called J.
Yeah.
Right. So
where's the fudge factor for the timing?
On this graph, the graph I'm looking at, which is on Shame's Facebook post, is that line that has no variation, basically.
Yeah. But if you see that
factor.
equivalent post on Twitter, I've responded with the actual globe predictions.
The blue line is a flat Earth prediction, fudge factor. Notice how tiny the variance is. Notice how, meaning it's probably not correct. Closer to zero goes more accurate. The two globular predictions are vastly wrong. Why are there two globe predictions?
Refracted and unrefracted.
Globe, delta, altitude, atmosphere on, globe, delta, altitude, atmosphere off. Minus d squared over 2r.
Is it d squared or 2d squared over 2r?
D squared.
Okay.
But I'm guessing this doesn't include your observation, or do they include yours and then just have a fudge factor?
Oh, yeah, they include mine, but they have a huge fudge factor because it took like 100 seconds to get it from, or 80 to 100 seconds or whatever to get it from matching globe using their method to matching flat.
Yeah.
And I brought up the two globe matching ones provided by flat earthers now. So when you're ready, switch to my screen share and I'll have something.
It's showing, yeah.
Oh, okay. So the one up in Canada did the southeast peak, number 2 peak of Mount Varley or whatever, and with Regulus occluding behind it, and did it from a public place. So he said I could share the coordinates and everything. And that's this first one. So we scroll over and let's see. What are, like you said, I should name my columns, huh? Okay. GE diff and FE diff. Arc minutes. So you can see it's 0.7 arc minutes below the globe prediction using the original Heffron method, and it's 5.2 arc minutes below the flat Earth prediction using the original Heffron method. So it's slightly below the globe prediction and much closer to the globe. So by their standard, because Pike's Peak was within like 2 arc minutes of flat, and they called it a perfect match. So 0.7 is by their definition a perfect match.
Wow.
And it's definitely closer. And the other thing, when we started pointing out that they had a lot of things that weren't even close to flat Earth, they said, well, it's closer because 2,000 feet above flat Earth is still closer to flat Earth because it's on the wrong side. 2 million feet too high would still be closer to flat Earth, but it's not close. So this is the one from Canada. And then the next one is one of Alan's, and I think Alan's got some more that I have not checked into yet, but this is the one we figured out. So that was a place, some mountains called Twin Peaks on a slope, and this star, and
Uh-oh.
That looks a bit closer to
matches
globe
a globe.
Yep, it's
Close, and
635 from below the globe and 3 below flat Earth. So, and it's too close to be super unambiguous, but still, it's
But like I said earlier, if they claim to negate refraction, where is the variability coming from?
right, exactly.
oh, but there is no variability because the fudge factor removed all variability.
Yes, makes it perfect match.
In fact, I'm gonna bring up something in a minute when I find it, so you guys can ramble on, and then I'll let you know when I have something.
What can I ramble? Put pressure on, Jesse. Jeez.
I've got some feedback from the audience.
Cool.
If we want to do that. Some jokes mixed in. Tim Davidson says to answer the thumbnail, which is, does this prove flat Earth? To answer the thumbnail, does it prove flat Earth? Short answer, no. Longer answer, no. Or as, hold on. Let me ask Dell.
No.
Hold on, where'd it go? Dell, does this match flat Earth?
No.
Thank you very much. We've got Jack Fetter says, would have you be kind enough to explain exactly what this would prove? And is stellarium necessary or just validation? Also, aren't they against using lights in the sky to explain the shape of the Earth?
When it suits them, sure. I think it's perfectly valid to use the lights in the sky.
Yes.
Yeah.
Well, see, it's like refraction. There's the non-real refraction, and there's the real refraction. There's non-real lights, and there's real lights.
Yeah. Oh, there's the Walter Bislin refraction, where you're looking south, and the refraction makes it appear like it's coming from the north, but it refracts 180 degrees back to the south.
Shame's a stolen model.
Yeah.
Yeah.
Swala. Shout out to Swala.
Oh, I see him there. Tim Davidson says, my boss said, how are you at PowerPoint? I said I excel at it. She said, was that an office joke? I said, word. And
Yes,
and
that's
for that,
pretty good.
Tim Davidson, I will be taking away your access.
That's pretty good. I make all my videos in PowerPoint. Just narrate over the top.
Oh, all right. Earthly Skeptic says, if Heffron was to do an RZA measurement, he'd measure the angle from one place and predict the angle from another place equals 180 degrees minus first angle and declare victory.
Pretty much. Yeah.
Earthless Life is a member at Newton here. We got Tim Davidson again says, not like I'm going to stop, but do you guys like my jokes or am I wasting money?
Solid joke.
I like that one. Still going to take away access. Tim, you know what? One of the first jobs I had, I wrote Fox Pro code.
That's a blast from the past.
Yes, I wrote code for Fox Pro. Tim Davidson says, as a child, I was made to walk the plank. We couldn't afford a dog.
I saw your comment earlier about we need to translate everything into Logo.
Yep.
Logo is one of my first ever languages.
It was
That's pretty good.
It was, yeah. I did Apple. I did Microsoft Basic, AppleSoft Basic, Logo, and then Assembler.
Cool.
That was my order.
Nice.
And then after that, Pascal. Earth's Life says, just ask Shame and Alan where the sun is at midnight in Stellarium. So I think this is an important thing.
I've asked that so many times to them. I say, is it an accurate direction or isn't it? And they don't have an answer.
Yeah.
Basically.
So have you seen the meme where it's like, the sun, Mercury, Venus, flat Earth, Mars, Jupiter, Saturn, right? You've seen that. And they're like, that's a straw man of our model. But wait a second. They're using Stellarium, and as their geometry, as part of the geometry where they claim flat. So Stellarium plots the stars in a sphere. So it is that model.
Yep.
It is that model. There is the flat Earth, and around that is a sphere of stars, and half of the stars are physically above the flat all the time, and half the stars are below the flat.
Yeah, as soon as you accept that there's a celestial sphere, it's over.
Yeah, you're done. It has to be a celestial plane
Flat.
or dome. You can't use a sphere.
And like I said, this spreadsheet that we've been looking at of Heffron's is so full of globe geometry. Like I said, it takes the right ascension declination of the stars, uses spherical geometry to work out azimuth and altitude of that star.
Jesse,
His brain must be mush.
could you link, and I'll put it in the description, could you link the your version of his spreadsheet?
Mine? Jesse's or mine?
Well, Jesse does it in Google Sheets.
Yeah, so mine's an Excel sheet, so I can send it to you on Discord, probably.
Okay. Do that, and I'll import it into Google Sheets so it can be shared.
Okay.
But since Jesse's is already in Google Sheets, I can just grab the same link.
There as it is.
The nice thing about Google Sheets is if somebody shares you a read-only copy, you can capture it and edit your own personalized copy of it.
All right, I've sent it to you on Discord.
Okay. All right. Jack Fetter says, doesn't adding 3-minute global stellarium error then negate his previous good results and now make those inaccurate? I don't know. That's for one of you two.
I'm still trying to display this PDF here. Hold on.
Okay. But I think Jack Fetter, I think you're right though. Like they're adding these things in for no reason other than to force the outcome. That's why.
Yeah. And he must know that.
Yeah, he has to. And and so either he is just content lying about it, or his, like you said, he has truly lost his mind to think that that's an acceptable or legitimate way to do something.
Yeah. That's the eternal question with flat earthers, isn't it? Are they crazy and stupid?
Or lying.
Yeah, or lying. Yeah. It's
and people when I say that flat earthers are lying, people, they take me up on that. And so when I just say, well, okay, fine. They could be lying or just so incredibly stupid that they don't know it. Take your pick.
Yeah.
All right, I see this PDF now.
Okay, so this was his outline for his outline presentation, kind of his slideshow for the last Celestial Theodolite Monday show they had on Geo's Earth of Whatnots. And I found a very interesting thing in it. He says, by perfecting the magenta line, it compensates each occlusion for any real refraction, uneven terrain, bearing errors, etc. So
when he says by perfecting the magenta line, what do you take that to mean?
Fudge factor. He's fudging.
Yeah, I think that's his fudge factor offset by the 2 globe drops or something.
Right.
Oh.
It's his fudge factor, but he's got it obfuscated.
Yeah.
It's basically him applying his correction. But he claims that his correction can correct for uneven terrain. So how could any correction correct for unknown uneven terrain? He's basically admitting that the actual occlusion time, because if you don't know the actual height of the mountain, then you don't really know the actual occlusion time.
Terrain doesn't affect the path of light.
Well, what he's saying is, like, let's say the occlusion point happened to be on a big boulder that caused it to occlude a couple minutes earlier. His method compensates for that without knowing that.
I got you.
Yeah.
Without knowing that there's a boulder there at all.
Right.
Yeah.
So in other words, it doesn't matter when the occlusion happens. It still gives perfect flat Earth results. And he knows it. And he's proud about it.
Oh, man.
That's just...
Scroll back to the movable type link. A bit up, I think. Where was it? There we go.
Yeah, there.
Like, from the start, they're using Haversine to calculate distances and bearings. Like, it's just the graticule, bro. Like, that's their comeback is, oh, it's the graticule, bro. And I'm like, holy shit.
But that's not... Yeah. It's just, let's drop in a word that their gullible audience will think is impressive.
Yeah. Pretty much.
Hey, is there any way you could get Shane on here to debate me?
Oh.
You could try, because I asked him a couple questions, and I think they're so sincere. Ruhif knows about the one. How can lines of longitude converge? Oh, you know about this too, don't you, Toon? You did your own measurement.
Jesse, that was your experiment.
I still need to put that. Has anyone made a video about that?
Yeah, Will did. It came out. It came out Monday.
Oh, cool.
Yeah.
It was 45 minutes of just constant flat Earth nuclear bombs going off. Just
So I've been asking Shane that question for a while. How can they converge going both ways? And he won't answer, and I would really like to discuss that with him.
It's just a graticule, bro. Dog.
And the other question I would like to ask him is, how is it possible to have 4 equidistant points on Earth when it's not possible to have 4 equidistant points on a flat plane? So he just runs from those questions.
Oh, yeah.
I think he got a job with Nike testing their new fireproof shoes, and he just runs.
Wait, who runs?
Like our friend in Telegram as well.
I just want to say, who runs?
The Shane?
Shane can't run.
Oh.
What the hell are you talking about?
Then what caught his shoes?
He walks his dog. He walks his dog. Come on.
What? His dog walks him.
Shane walks his dog.
His dog walks him.
Probably.
Does Shane have a dog?
Yeah.
Are you serial?
Super serial.
Oh. Poor dog.
Well,
shall we wind it up?
That's about all I can think of to bring us about the celestial theodolite. As I said, it's in shambles. I don't know what they're going to do. I don't even think they know what they're going to do.
They're going
tactics.
They're going to continue talking to their echo chamber and pretend that what you are talking about didn't happen, and not let because nobody knows, none of their followers know what Heffron did to get to where he is now, and so he could just add another column of fudge and they still won't know because none of them can do the analysis.
Oh, can you make me full screen for a minute?
You are.
I got to point at the audience. I got to point at the flat earthers in the audience.
You want to be full screen. All right, just stop your share.
Oh yeah. Okay, stop share.
Okay, hold on. Here we go. And then, and one more thing. Hold on. We're gonna get it. This is gonna be good. All right, now you're full screen.
All right. Okay, so I know there's gonna be some flat earthers out there who are gonna tell me that I'm misrepresenting and I'm not doing it right or whatever. The fact is, I know that not one of you knows how it works. Alan doesn't know, Aether Piezo doesn't know, and Dr. Heffron won't tell me what the step-by-step correction procedure is with the angles and the time. So I know none of you know. So before you go telling me or anybody that I'm misrepresenting and I don't know what I'm talking about, you get on here and debate it with me. Okay, that's all I had to say.
That was fantastic. Fantastic.
Nice. All right, let me.
Yeah, it's a bit embarrassing to see Shane just post that flat blue line or red line or whatever, saying it's perfect, and not realizing it's just 100% fudged.
Well, yeah, because Shane doesn't know what's going on for sure. Oh, amazing.
Yeah, I reckon he gets his little self-trained ChatGPT to respond.
Oh yeah,
to most tweets.
Yeah, flat GPT.
Yeah.
All right. Well, I've got a few more super chats and stuff. You guys can stick around or whatever, but
yeah, 10 minutes.
I'll stick around a bit and see if a question comes up for me. Because if there's a flat earther out there that has any questions, I am totally glad to answer them. I don't run from them, and the flat earthers will not debate me on this because they don't even know what it is themselves.
No, they don't know the process. Earthly Skeptic says, do the stars set after passing the mountain? Ouch. Yeah, it's a celestial sphere. By their own admission, half of the stars are under the flat. Cal says, yay, Tuesday. Jack Vetter says, I've worked out my own model. If you triangulate using precise length of Heidi Klum's inseam, you can calculate certain objects' exact girth. There you go. That's a popular method. Jimmy Madison 42 says, well, it looks like we can stick a fork in any data from them on this method of star occlusion as proof of a flat Earth. They've been caught.
Oh, they have been caught. Caught.
Jack Vetter says, okay, so if I'm reading the room right, you've proven his theory. It's Miller time. Let's call it BS global adjustment theory. Use liberally. Claire Celestin says, I used to believe that naan was my favorite type of flatbread, but I just saw the recipe and it uses the Haversign formula.
Oh, that one's good.
I like that. Earth is Life says, it's just hilarious how we can now look at the stars to prove the shape of the ground when before this celestial theodolite nonsense, flat earthers complained that we couldn't. I think the first thing that should be asked in a conversation about this is, can you use the things in the sky to determine the shape of the earth?
Yeah, exactly.
Because if the answer is yes, then all of these other things they can't deny, including the 24-hour sun in Antarctica.
Yep. Lisa, I have not ordered, but looking at Redbreast 12-year-old Scotch. Thank you for the recommendation.
Is it like expensive? Like you have to consider?
I could run down the road, get one for 140 Aussie dollars, Aussie fun bucks.
For how much?
That's 700. Yeah.
700. Okay. And how big is this
about
guy?
100 US, right?
700 milliliters, right?
Yep.
This
so
is
24 ounces, something like that.
Well, in America, for some reason, everything else, right? This is in ounces. This is in milliliters.
That's because it belongs in a laboratory.
Anyway, so this is belongs in a what?
A laboratory. A laboratory.
Hold on. I'm looking. This doesn't say. I don't know. People in the chat who do more than consume this more than me know what size this is. I know it's the large one. 1.5 liter, maybe. I don't know.
Yeah.
This was like $40, I think. Anyway, okay. Jack Fetter says, I kind of feel bad for Beavis and Butthead. They literally both had erections over this theory when presented in that debate. So sad.
Yeah. And Whitsett as well, right?
Whitsett is so out of touch. Right? He's I don't know what he's doing. Right? He only does a live stream like every 2 or 3 weeks. And of course, in that live stream, every time he's like, yeah, so like bros and dudes, like I'm going to totally be doing more like every day or like twice a week or 5 times or 73 times a week. I'm going to be like doing live streams for everybody. So, cause I'm back now.
Was it a year ago now? And he said, we've completely solved celestial navigation.
Yeah.
Is that a year ago?
That was more than a year ago. I think it was like March of last year. And of course, he was talking about Shame's plagiarized model.
Yeah.
That's what he was talking about. But yeah, it didn't go very far.
No, haven't heard much about celestial navigation and Whitsett recently. It's dropped off the list of flat Earth proofs.
Well, no, celestial navigation. Just the other day, somebody sent me that video from the guy that said, boom, only 284 nautical miles off. That was just a couple. And of course, here's the thing. He's an Oakley fanboy. I could tell by the people commenting on the video. Neil is Oakley's little lapdog.
Yes.
Neil is commenting.
He's like 5'2", and he's something like that.
Yeah, I mean he's the Joe Pesci from Lethal Weapon. Yeah. That's Neil. Yeah. And so he's commenting in there. He used this map, which Oakley's like, you can't use that map, but he did. So how do you do celestial navigation without something? You got to use something.
Yeah, like you and I differ on the celestial navigation challenge. Like you won't let them use the AE map because it's a projection. I'm like, fine, let them use it. But you're not going to get 3 intersecting circles on the AE map. So you may as well let him use it. It's like,
Yeah. Well, I wrote it. The thing is, I wrote the challenge, right? And then I looked at the challenge, and when Brian Leakey submitted it, you know, the challenge says you can't use globe anything. And so he's like, he used the globe projection. I'm like, well, that's one of multiple different things that you use that you can't use. So that's just one. But my point is,
I've said to plenty of people.
Oakley says you can't use that.
Okay.
Right? He used to. There's a video still on his channel where he's got a projector, like a video projector onto a screen behind him. And then he's sitting in front of it, so the projector is shining in his face. And he's like, look, here's this, and this works better on this, and the ice wall around the outside. Oakley's actually, it's still on his channel.
Yeah.
Right? But as soon as he's like, oh, crap, that, you know, that's his claim, gotta retract all claims.
Yeah, in the chat, M Stone says, Rui had hair at the beginning of this. Like, no, I didn't.
M Stone.
Yeah.
Why don't you get on and debate me, buddy? M Stone. You kind of run away last time we had a discussion.
What?
Man of Stone?
Someone else.
The Man of Stone?
No. M Stone, different guy.
Oh, my apologies. Well, Man of Stone is out there.
Yeah.
M Stone has been around a long time. He was at the Flat Earth Convention in 2019.
Oh, wow.
Wow. Oh, that's right. And he confronted Robbie Davidson? Who was it?
I don't know. There was some doings that had transpired.
Yeah. Who did you have the running with at the convention?
Well, it's a pretty good bet to say Nathan Thompson, because Nathan Thompson likes to have run-ins with everybody.
Yeah.
Okay. While he's answering, Jack Fetter says, send this to the school that gave him his degree. All of $2. Christian Hoage has been a member for 5 months and says, amazingly enough, this is the closest the Dirt Pizza have come to somewhat valid hypothesis. Still wrong, but they tried. Icider74 says, so like always, they run with things as soon as they think they have something. When you look at things, it confirms the globe.
Yeah. And for the fifth time, that the geometry they use all through that spreadsheet, just globe. Yeah.
I am impressed that Dr. Heffron actually was able to put in the right ascension and declination so that the spreadsheet could calculate the star's apparent, or elevation angle and azimuth based on time adjustments in the sheet without having to actually load Stellarium. I thought that was pretty impressive, actually.
Oh, you can ask ChatGPT for the formula, and it'll give it to you.
You probably did.
Yeah.
Probably asked ChatGPT to write him the formula for Excel.
So, here's the absolute unavoidable challenge for flat earthers is it is valid to say, let's apply the globe and test the globe and see if it fails, right? And so you use Haversine to test the globe. You use Stellarium to test the globe, right? But as soon as you're like, oh, well, we're then going to compare to the flat earth prediction. Well, you can't use Haversine. You can't use Stellarium. You can't use the celestial sphere. You need to use the polar distance formula. You need to plot the stars in the celestial dome, right? You need to use, you can't use Stellarium because because that's the globe everywhere. You have to use the flat earth geometry for all of those things. So you never ever enter into the arena of, well, this is evidence for flat earth, until you actually only use flat earth geometry, which they never do.
So Heffron.
Hang on. M Stone has responded. I knocked Nate's hat off and had an unfortunate spell with F.E. Fokker and talked to Jaren for about an hour. That's a wild memory. RIP, R.I.P. George Natchik.
Yeah, George was there.
Oh, wow.
Yes, now I remember he knocked Nathan's hat off. Nathan, I'm surprised
Naughty boy.
Nathan hasn't been the recipient of the thing that Mikey Smith almost received the other night.
Yeah, that was a bit rough, wasn't it?
That was. So I don't know, you maybe didn't see that, Jesse, but Mikey Smith was in a car talking smack at another car near him, saying, "Hey, ladies, maybe you should have a guy that's older," talking about himself. And so one of the younger guys in the car got out, walked up to Mikey's open window, and punched through the window, missing Mikey. But it sure made a good music video.
It's a dick.
Why would anyone? That's like asking for trouble.
It wasn't clever, but still.
That's what Mikey does. He asks for trouble.
Yeah.
Jack Vetter says, "Son, did you cheat on that test?" "No, I simply applied the magenta line variance."
By the way, Dr. Heffron is claiming that Stellarium internally uses a flat Earth model.
Well, now
It's open source.
it's open source, and to the best of my knowledge, doesn't Mike Heffron have a PhD in computer science?
Apparently.
So he could back up that claim by just examining the source code and pointing out where it's using this flat Earth model.
You know, he got the PhD in 2001 or something,
Yeah,
right? He might have lost it since then. It's a long time.
He could have.
His brain has turned to mush in the last 20 years, has to have done.
This. All right, here's what I need.
Yeah.
Who wants to purchase a copy of this?
Yeah, I'll get it.
And then we look at the gravity chapter and we do a video on it together.
That could be fun.
Do that. It's
All right.
like, it's the same thing. It's this is the same process as the celestial theodolite. He started out by applying, right? He took the base method, he took the things correctly, and then he's like, oh, well, if we do this, and then we do this, and then do a bunch of ridiculous things that you would never do for no reason at all, then everything falls apart. Therefore, gravity, not real. But why did you do all of those ridiculous things? That's the challenge. Dave's app is still leaking data. 8 months later, almost 9 months later.
And he had some almost an advertisement saying, I'll give you 2 million free Dome coin if I get a referral to the app. So he's still pushing it pretty hard.
Yeah, he's been reported for securities fraud.
Nice.
Because Steve from Wormhaven, he looked at the dome shot or blowjob coin, and determined that it looks to him like it's a securities and it's an unregistered security, so reported him to the SEC.
Nice.
All right, we got iSolder74 says Flerfs outrun the Flash.
I sold a 74, thank you.
Emerson Biggins says, ask Jesse about the status of his string across the lake experiment.
Oh, I am hoping to do that this summer. I've got everything ready, I think. I still need to make a little mount on the canoe that'll hold the spool of 6 kilometers of string while I motor across the lake, and I still need to do a 1 or 2 hour burn-in test to make sure the motor can go continuously for an hour without blowing up.
Wow.
It's a little 3 horsepower 1968 Esca outboard, 2-stroke.
So what is this test?
Oh, okay. Let me bring that up, and I will show you. Basically, the idea is to stretch 6 kilometers of buoyant string out across the lake and pull it really, really tight.
All right.
Let me screen share here. Where did
Force the line, yeah.
I like to call it force the fishing line.
I've got to go in 4 minutes, people.
All right.
Okay. All right. Do you see an MS Paint style
I see it, yeah.
diagram? Okay. So the idea is take buoyant string, and I found some PE braided fish line. I've got 6 kilometers of it on a spool right now in my bedroom. And
who doesn't?
what? Yeah, who doesn't? Yeah, okay. And so the idea is to take the string and put it out on the lake and then pull it as tight as I can and have 2 GoPro waterproof cameras in the middle filming it against the backdrop of a yardstick with lights. So if I can pull that buoyant string underwater, then that's pretty good evidence that the lake is not flat.
So you'll float a something out there in the lake?
Yep, I have made a kind of a round styrofoam buoy with, no, maybe it's not round, I don't remember. Actually, I got it. Let me grab it. It's in the room here.
Okay. Emerson Biggins has 20 feet of velvet rope in his bedroom.
Nice.
Oh, yeah.
Jack Fetter, that's a good one.
Jack Fetter says, I still insist Mikey was saved by the globe Earth. That kid missed a full-on clock cleaner partly due to the Coriolis effect.
Nice.
Okay.
Oh, that's great.
Does this show? So I've got a styrofoam platform, and underneath I have, let's see, can you see the ruler in there?
Yeah.
And I've got, it's kind of big and awkward here, but I've
Hang
got
on.
two.
Stop your screen share so we can see the full screen.
Oh, yeah, that's a good idea. Okay, stop the share screen.
There we go. Yeah.
Okay.
Oh, there we go. Okay, yep.
Yeah, so I've got, can you see both GoPro mounts or both waterproof GoPro mounts?
Yep.
They're looking at the ruler, and the string will go right between here and in front of the ruler, which is just a smooth, so the string can go up and down. This will just be floating out in the lake on the string, straddling it, but not attached to it. So hopefully the string can rise and sink as it wants. And then I've got lights built in.
Oh, man.
Oh, yeah.
So it'll be fully illuminated underneath there. And then
You're the man, Jesse, by the way.
I've also got a holder right here for a waterproof clock. I made some waterproof clocks. I got 4 little digital clocks, travel clocks. They were cheap, but I'll have them all synchronized. I'll show all the clocks in the same camera at the beginning, and then there'll be 2 cameras in the middle filming the string just as redundancy in case one camera quits. And then there'll be a camera at each end filming the fact that the string is at the surface at each end. So we'll be able to know that, it was at the surface at both ends, and then how deep it went in the middle. And
Very
all
cool. And you got the clocks at both ends and everything, so it's all
right,
able to
and
be
then,
synchronized up. Yeah.
Right, so there'll be a clock at each end, in the middle, and then a 4th one at the observer end where we'll be tensioning the string with a scale that measures the tensioning.
Yeah.
So, and then in the end, I plan to bring all the clocks back together and show them all on the same camera to show that they still have the same time synchronization. So that way, there won't be any question about how to synchronize the videos. They'll all be time-stamped in the actual video frame.
Awesome. All right, that's me. I got to go. Thank you, Mr. Toon. Thank you, Jesse.
Thank you, Ruhiv.
That was
Thank
fun.
you.
All right. I'll see you guys later.
All right. That looks like a fantastic test. Now, I know a Flatty did an attempt at that.
Yeah, and he consulted with me extensively before doing his to try to, and I helped him as much as I could to get, the best he could. Samuel, I can't remember. I think he's in Austria, I believe, or something like that.
And he swam out into the water at the middle, but if I remember right, like the line snapped.
Yeah, he didn't have it very far. He didn't have it very far at all.
Oh, yeah, it wasn't. You're doing 3.7 miles?
Yeah.
And what's
Yeah,
what's the Sagitta there?
So the straight line Sagitta would be 28 inches.
Okay.
But obviously the string is buoyant.
Yeah.
So it would take infinite force to pull it perfectly straight.
But if it goes down at all,
right.
That's evidence of the existence of a Sagitta or Sagitta.
Right.
However it's
of some sort.
Pronounced.
Right. Yeah, it's not a quantitative, it is a qualitative test.
Yes.
It would demonstrate curve, but not exactly how much. It would disprove flat, though. That's what it would do. Because, if the water's flat, it doesn't matter how tight you tighten it. Straight is still the shortest path, and so it's not going to have any desire to sink just if the water's flat.
Yeah. Well, that's really cool.
It is a long shot because the amount of downward force you can get on such a large radius curve is extremely low. And the string has about 1 milligram per foot of buoyancy. So I used an online catenary curve calculator that told me the sag would be a certain amount at a certain tension for a certain weight of string. You can put all that in.
Oh.
And based on that, it should pull about 10 inches under at breaking tension.
Okay, so the nice thing is, though, the way you have it set up, you can go until it snaps.
Right, yeah.
And it will either go down or not.
Right.
So,
but I hope it doesn't snap, especially at first, because I want to, tension it and then slack it and then tension and show that it's not just sinking. I want to actually show that it goes up and down, and that correlates with tension.
Oh, yeah. That's
because
very nice.
That would eliminate the allegation that, well, it just happened to sink and you assumed that it was because you tensioned it. If it goes up and down repeatedly. So I did some terminal testing, and the string is rated at 100 pounds, but it's from China, so it broke. I had it to 90 once, and then I let it slack, and I had it to 90 a second time, and it immediately snapped.
Oh.
So I probably will try to not take it past 70 or 80. And besides, if it doesn't break, then that's easier to get it out of the lake.
Yeah, that's true. And you're not certain if your boat motor will function well enough?
Yeah, someone gave me a 1968-esque outboard. And I'm a mechanic, so I, renewed it. I put new gaskets and seals and everything and got it running good.
Oh, wow.
But it runs a little bit hot, like 270, 250 degrees Fahrenheit. Or no, Celsius, centigrade. So it's a two-stroke. Two-strokes do run hot.
Yeah.
It's air-cooled.
Okay,
it's air-cooled.
Okay. So it's not like the 4-strokes, they pull water in from the lake, circulate it, and spit it back out.
No, this is like a lawnmower in 1960. In fact, this same engine was used on lawnmowers in 1968. It's a Tecumseh engine, and they literally had little lawnmowers with the same engine on it. So
fun fact about 2-stroke lawnmowers. A lot of lawnmowers, are 4-stroke.
Yeah.
But the Lawn Boy lawnmowers were 2-stroke for the longest time, right?
Oh, wow.
And so if you're fun fact for everybody, if you're planning on launching a lawnmower with your trebuchet, you want to get a 2-stroke lawnmower because it won't stall while it's in the air. I learned this through experience. So what you do is the first step is you defeat the safety mechanism. Now, if those words come out of your mouth when you're doing a science experiment, you're going to have fun. Okay, so you defeat the safety mechanism. you fix it so that it's on at full throttle, and then make sure you have just a little bit of gas in the engine, and then you launch it. And when it's in the air, it's going full speed. It's amazing. And then when it hits the ground, of course, for some reason, things stop working. But then it goes from really loud to really silent in just that amount of time. It's really nice. One of the best things ever.
Anyway, so I've never done an endurance run with it, so I don't know if it will overheat running continuously for an hour or however long. And the boat only makes the boat go about 6 miles an hour. So if I'm going 3.7 miles out and 3.7 miles back, I'm going to be running that thing wide open for a fair amount of time.
Yeah. What about other boat traffic on the lake?
I'm doing it in a location that does not cross any boat launches and does not cut off any docks or boat launches or public access areas.
Okay.
Really. So, and I may try to do it on a rainy day just to reduce other people out there.
Yeah. All right. Good plans there, and still just hope a little bit. You plan and then hope. Okay. Emerson Biggin says, ask Jesse about the status. Oh, I already did. The string across the lake. Unfornicated says, 1, Battle of the Beams. 2, Celestial Theodolite, both dead. What's the next globe killer? Yes. Well, they'll still claim Battle of the Beams.
Oh,
right?
Yep, I heard that the other day.
I got books back here. But yeah, it's yeah, Whitsitt was talking about it in Antarctica. Not in Antarctica, when we were in Punta Arenas. He was going on and on about it.
Oh, wow. Yeah. He still owes me those 30 PDFs when he gets back from the gym from a year ago.
The PDFs on what?
Curved visual space. He and I used to get these arguments about curved visual space, and he was like, sorry, bro, brother, I got you, but I'm at the gym. When I get home, I got 30 of those on my computer.
Yeah. Yeah. Were they generated by ChatGPT?
No, they were about curved visual space.
I know, yeah.
Which doesn't have anything to do with the visual field or theodolites or anything that matters.
Yeah. I've read several of them, and they use theodolites to measure the distances.
Right.
And then have humans evaluate how far they think something is away from themselves or between different objects.
Right.
And the whole point is us as humans are not good at measuring distances with our eyeballs.
Right, but it's never, and all those tests, it's never sighting. Like, let's say you've got two things and you're sighting along them. You can line it up. That does not depend on visual space because they're, you're sighting along them. All the tests, have two things, oblique to you, and you're trying to tell which one's closer and what the angle is, but you're not allowed to sight along them. You're looking at them from the side and behind. And so it's completely irrelevant. And he knows it because he quit bringing it up in my presence there once we talked about it a fair bit, but he still brings it up in other venues. Well,
yeah, Whitsitt doesn't bring it up anywhere because he for some reason seems to be very sparse in the conversation.
Didn't he bring it up on his debate with Jaron? Briefly mentioned curved visual space?
Well, yeah, I think so. He does talk about it. Yeah. But I mean, his last debate was pre-TFE, I think. Before Jaron. Yeah, but other than Jaron. So, yeah. And has Whitsitt been in the Either Cosmology Discord server with the rest of the?
I think he's always been there, but I'm banned from there for being me.
Oh.
But he has stopped by Geo's a couple times.
Yeah.
I don't know if he said much, but he was just kind of lurking and maybe said a little bit. But I wasn't really listening. I wasn't in the VC at the time. I was busy, but I did get in a little later and did tell him I was still waiting for those 30 PDFs.
Oh yeah, Witsit did debate Nemos. Thank you, Debunks, DP Debunks, on whether or not he actually went to Antarctica. But not, his former best bud. Austin has a long list of former best buds. You got Nathan Thompson, you got Dustin Nemos, you got Kai. Oh, sorry. Never mind. I shouldn't have gone there.
Dustin Nemos isn't he kind of an odd character himself?
Oh, absolutely. Dustin Nemos apparently was a former stripper or male dancer or whatever.
I don't know if I needed to know that.
And he's he's hyper religious, and likes to call everybody he doesn't like, that thing that people who have no evidence call everybody they don't like. That thing.
Flat earthers?
No, they accuse other people of doing things with people that can't vote yet.
Oh, got it.
That's the baseless
that like
baseless
something.
assertion. He likes to do that. The hyper religious guy who was a male dancer. Anyway, he also definitely thinks that the Jews are I won't.
It sounds like the same. It sounds like the same
popular
guy.
amongst the flat earthers, that mindset. So yeah.
Yeah, I was trying to get him to debate me on Jaren's back before TFE, but he kept running.
Yeah. Scotty Orange says flatty angles have a supernatural player. Could it be Jesus? They do often, they sometimes they get cornered and they're like, oh, it's just God. It's just it looks like a globe, but it's flat because God made it that way.
Wasn't that kind of a concession, though, that we're completely legitimate to argue that it measures as a globe?
Oh, yeah. Yeah. If all the evidence supports globe and you're like, oh, but it's still flat because God. Yeah. Like, okay, so it's a globe then, is what you're saying.
Yeah. Yeah.
Larry Scott, good old Larry Scott, Shoebill. He says, my CellNav solution and Stellarium confirm A, lat long, B, instrument accuracy to the few seconds, C, UDC time, D, field methods, Celestial Theodolite, great QC method, quality control method. So yeah, the accuracy of Stellarium, the time claim of that this PhD in computer science made, he should definitely
it's absurd.
It's an open source project, so he should go identify the issue, publish it to show how how smart he is, and then do a pull request set to the GitHub repo. Nah, I don't think he's going to be doing that.
And I've checked my Theodolite against several stars or planets and checked Stellarium, and it is very, very close. And I'm actually going to screen share one where I did the sun.
Ooh.
If I may.
Yeah.
We have time for that? One more quick screen share? Okay, do you see kind of a pink purple sun?
Yes.
All I had for a solar filter was an old floppy disk, so I used that. Those work pretty good. You open them up and you take the... Yeah, except I had an 8-inch one.
There you go.
Yeah. But you can use the little ones. You just slide the little window open, you can peer through it, or you can take it apart. I got some 8-inch ones off of eBay to use for solar filters.
Nice.
Anyway, I lined up my Theodolite the best I could to the sun. It's tricky because at the 30x or whatever, the sun's just never still. It's always moving. You can't just line it up and it stays lined up. So at the moment I snapped the picture, you can see I was a little bit off from the center there, but that's okay. I know how many much of a degree the sun is, so I know how many pixels per degree there is. So you can see I've compensated here for the pixels per, or the offset from the center of the picture, or the center of the sun and the center of my crosshairs. And so I add that 50 seconds of elevation angle offset. And so I measured the sun to be at 26 degrees, 39 minutes, and 17 seconds. And Stellarium said for that point in time and observer location, it'd be 26, 39, 14. So with no prior expectation of what I would get, I was still within 14, 15, 16, 7, still within 3 arc seconds.
Wow.
Which is like, almost nothing, and would be very easily within the margin of uncertainty just due to me trying to time it.
Yeah. Wow.
I found that my cell phone clock actually is not always perfect timed. Sometimes it is, but it can be up to almost a second off because it drifts, and then eventually it gets set by the cell tower networks, but then it drifts. And so anyway, so yeah, to say that Stellarium is wrong, especially in the order of minutes.
Yeah. Well,
it's absolutely absurd.
That's the type of thing that can be substantiated.
Right.
Especially by a PhD in computer science.
You would hope. You would definitely hope.
No, there's zero excuse. I agree. Absolutely have a professional responsibility if you're going to claim that there's an error in Stellarium.
Right.
To point it out, not just say it. You are the person who is uniquely qualified to seek out the specific error in the source code, which is open, and point it out, and at least show where that error is.
Right. Exactly.
And then to be a proper member of the open source community, report that error back to Stellarium in a pull request.
Right. Yeah. Now he's just trying to come up with excuses to apply drastic fudge factors.
Yes. All right. We got one more from Scotty Orange. Again, says, do flatties depend on a supernatural being like Jesus? They generally do. Flat earthers generally are. They generally say that, they point to the Bible, and they like to claim that the Bible supports their position. Of course, it doesn't.
Most of them, though, don't behave like they have any reverence at all for the Bible or Jesus, or, I think they just want to be anti-mainstream, and they see that as a way of being anti-mainstream. I think that's what's going on for most of them. Some of them are sincere Christians, but most of the ones that tell you about it aren't.
Yeah,
that's been my experience.
Yeah, you don't have to spend much time looking at flat earthers to see that the way they act and behave in general, not all of them, nothing similar to what you'd hope. As it said, there's no fruit on the tree.
Yeah, exactly.
Go watch Quantum Eraser, and remind yourself that he claims to be a Christian.
Right.
No. Anyway, but yes, Scotty Orange, they generally do. Even Dean Odell, who is a pastor, he from the pulpit says that he wants to take me out behind the woodshed and beat me up. From the pulpit. Good job, Dean. He's running for lieutenant governor of Arkansas.
Well,
also,
if he gets in there, I would make sure you don't live in Arkansas or any states neighboring Arkansas.
I mean, Arkansas has a giant NASA facility.
Oh, would he shut it down?
Well, he doesn't. The governor,
right,
even
federal.
if he were governor, he wouldn't have the ability to do that. But
yeah.
But Is that the kind? Do you want that kind of person having any sort of decision making ability in the government that would, if given the opportunity, shut down everything space related?
Yeah, or want to beat people up behind sheds.
Yeah. So,
Well,
all right.
I think we covered about all I can think of.
Yeah, we did.
So I'm thinking it's about almost 11 here.
It's almost 1 here. So,
Oh, wow.
Jesse, thank you. Yeah, it's my early bedtime is 2, so I gotta
okay.
watch. Jesse, thank you for spur of the moment. Basically, a very little time to prepare, and it was absolutely great. And I think that I hope this video can be something that we can point to say, look, here's how it works, or here's how they try to make it work, and here's how it doesn't actually work.
Yep.
So,
Yep. Here's what it really does. Yep. Well, it's my pleasure. Thank you so much for inviting me on.
yeah. All right, everybody. We'll see you later. I'm out for the weekend. I'll see you next Monday or Tuesday.
Yeah, YouTube, of course. Yeah, exactly. That's a good one. That's good for the ladies to hear, right? They like that. When you swear. It's very attractive. Hey, ladies, if you want a real man, you might want to get somebody older. More mature. More mature. Huh?
More mature.
Buddy? Hey, I got this on YouTube, pal.
Rolling down the highway, decals galore. Flat Earth preacher, Mikey's out for more. With a bumper sticker sermon, scrolling neon lights, spreading cosmic nonsense, picking verbal fights. Squawk that chicken, Mikey Smith, preaching flat Earth, the cosmic myth. Traffic preacher, making a scene, rubber chicken squawk. Know what I mean? Stop in traffic, tension thick. Mikey mocked a stranger, thought he was slick. The guy stepped out, said he'd had enough, delivered a lesson, calling Mikey's bluff. Squawk that chicken, Mikey Smith, preaching flat Earth, the cosmic myth. Traffic preacher, making a scene, rubber chicken squawk. Know what I mean? A punch flew swift, Mikey took the hit. Rubber chicken hunked, he lost his wit. You're going to jail, Mikey loudly cried, but the crowd just laughed, shook their heads and sighed. The moral of the story, keep it cool and clear. Flat Earth's got no business causing trouble here. So don't harass your neighbor, don't provoke a fight, or a rubber chicken squawk might be your only right. Squawk that chicken, Mikey Smith, preaching flat Earth, the cosmic myth. Traffic preacher, making a scene, rubber chicken squawk. Know what I mean? Yeah, Mikey Smith, with your theories and your squawk. Best keep rolling, less preaching, more walk. Keep that chicken silent, keep the peace intact. Flat Earth funk, that's a cosmic fact. Oh, yeah.
Yeah, now that all the sheep are out, let's go drive around and see how many people yell at me.